in geometry. We are on day 5, which it is Monday. Put that on the date over here. Monday, October, is it the 13th today?
Yes.
Okay, October 13th. Perfect. And today we're planning on reviewing everything in Unit 1 to get ready for this quiz. So, numbers 1 and 2 are both where you're solving for x using the segment addition postulate. So, the segment addition postulate, quick review of that. If I have two smaller parts and one whole, when I add the smaller parts together, it equals the whole. So if I'm trying to solve for x in number 1, would anybody like to be brave and tell me what is a good way to start this problem? What equation could I write?
Enjoying it.
Go ahead. 5x minus 3
Plus 3x minus 2
Good.
equals 19.
Yes. Plus 3x minus 2. I guess I don't have a green marker. Okay. 3x minus 2 equals 19. Okay, and whenever I have a big equation like this, where I know I've got like terms, I've got things I'm going to have to move around, I love to draw a line through my equal sign. That really helps me stay organized. So now that I have the correct equation written, what is my next step?
Combine your like terms.
Yes, 5x plus 3x.
8x.
And that gives me 8x. So I've done my x's. What other like terms do I have?
-3, -2.
Yeah. I've got some fun. Yes, good, Jacqueline. Good. So I have -3 and -2. When I put those together, I get -5. Good. And then we just bring everything down. 8x minus 5 equals 19. And that line you can already see is really going to help us stay organized.
You add 5 on each side.
Yes. You might have got things mixed up. So we're going to add 5 to both sides. And that will cancel our 5.
So give you 24.
I'll bring everything down. 8x equals 24.
And then you divide by 8.
Mm-hmm.
And your x,
By 8.
your x equals 3.
Beautiful. So you see, all we did is we put the pieces together. A plus B equals C. We combined like terms. We solved the equation. We got x equals 3. Now, once we have our x solved for, let's say I wanted you to find the length of one of these segments. What if after we found x, I said, I also want you to find BC? How could I do that?
5.
Yes. Go ahead, Jacqueline.
3 and x is equal to.
Yes. So we're going to use points B and C and look to see what's labeled. Well, 5x minus 3. And we know that x is 3.
Okay.
So we can plug that in.
Plug 3 into the x.
Yeah. And we'll have 5 times 3.
15.
Minus 3.
5 times 3 is 15.
Good. Minus 3
It's 12.
is 12. Beautiful. So we have x and we found BC. Good job, guys. Very nice. Okay, that's number 1, segment addition postulate. Let's look at number 2. Same kind of problem, but now different numbers. So I have 2x plus 22, and I have 3, and I've also got x plus 17. How can I write an equation? Jess, you want to tell me the equation?
Yeah.
Okay.
Plus 22 plus
Okay.
3
Perfect.
equals x plus 17.
Good. So I've got 2x plus 22 plus 3 equals x plus 17. And this is another really good problem to draw a line down the middle of your equal sign, because we have like terms all over the place here on opposite sides. So
It would be easier to subtract an x on each side.
yeah, so you're thinking right away, let's get our x's together. Sure, let's do that. And you're saying it's better to subtract x than it is to subtract 2x?
Yep.
I agree. So let's subtract x from this side, and we'll subtract x from the other side as well. And what happens when I do that?
Your x's cancel.
Good. My x's on the right side cancel.
And then you just put a single x.
Yeah, 2x minus x is just 1x.
And then everything else comes down.
Everything else comes down.
That would be x plus 22 plus 3 equals 17.
So now I have x plus 22 plus 3 equals 17.
And then you can combine your 22 and your 3.
You sure can. Yeah.
25.
That would be 25. 22 and 3 are like terms, so we can add them together and get 25.
And then you just bring everything else down.
And just bring everything else down. So I have x plus 25 equals 17.
And then you subtract 25.
Good. Subtract 25.
It's going to be negative 8.
Let's see. Equals 17 minus 25. You said negative 8?
Yes, ma'am.
That is correct. Negative 8. Good. So we should get x equals negative 8. Now, what if I wanted you to find RF?
You would put 2x plus 22, but you would plug the negative 8 into the x. So it'd be 2 times negative 8, which brings you to negative 16 plus 22,
Perfect.
which brings your RS to positive 6.
Beautiful. Beautiful. So I'm going to write all that out now. We can do it slowly. I know RS is right here, R to S, 2x plus 22. And I know x is negative 8. So we can replace that. Instead of 2 times x, 2 times negative 8 plus 22. 2 times negative 8 is negative 16 plus 22. And we should get RS equals positive 6. Okay. How do we feel about those? Feel okay? Okay. Okay. I'll leave that up for a second. I see a few people still writing. Yes.
So confused.
confused at this part.
First part.
I don't understand why is it negative or minus x instead of adding the 22.
So you can add the 22 and the 3 first if you want. With these problems, because there's so many different steps, you can do them in different orders. So if I wanted to, I actually, yes, and that's the way I probably would have done it too. I like to combine my like terms that are on the same side first. So let me write it out this way, and you tell me, Elena, if your work was like this. So 2x plus 22 plus 3 equals x plus 17. And instead of minus x first, could you just say, okay, here, these are like, so 2x plus 25 equals x plus 17. Start there.
That's how I got mine.
Okay, perfect. So this is a correct way to do it. And then what would you want to do from here?
Do the minus x?
Yeah, absolutely. You can do that. Minus x. And then we would get x plus 25 equals 17, which is the same thing we have right here. X plus 25 equals 17. Just in a different order, and that's okay.
And so on.
Yeah.
Get the same.
Perfect. We have the same last step, same answer. We would still get x equals negative 8. So there is no real like rhyme or reason as to which one you do first. It's really just your preference. If you like to combine your like terms on the same side first, do it. If not, that's fine. As long as you're following the rules of math and the equations, then you should be good. Any other questions? Okay. Let's look at number 2. So or I guess not number 2, number 3. So for number 3, it says use a protractor and a ruler to draw each angle. So on your quiz, I'm not going to be having you draw an angle necessarily, but this is a good way to practice making sure we know how to read a protractor. So first of all, you need one of these, a protractor. Make sure you have one. And whenever we are looking at this, we have a ray right here. Even though they didn't draw the arrow, I know I only have one end point, and this end goes on forever. So when we are using a protractor to draw an angle, we want to take that protractor and line it up with the ray. So I want you to put that pole at the bottom in the middle, about where the ray is, and then we want to line up our line with the other end there. Now, these protractors are not accurate. If they were accurate, that hole would be lower. It would be about right here. So that bugs me a little bit, but we're just going to pretend that it's accurate. And now we want to draw a 20-degree angle. So this is where the issue lies. Is this the 20 we're looking at? Or is that the 20 that we're looking at? There's 2 different 20s. Oh.
That was the question that I had. It's like, how do you know which side to use?
How do you know which side to use? So let's think about it. 20 degrees. Is that bigger than 90 or smaller than 90?
Smaller.
Smaller. And I know that a 90-degree angle is straight up and down like this. So should my 20-degree angle look more like this or more like that? It should look more like this. It's going to be a little angle. So if this is where my starting ray is, does it make more sense for me to use the 20 over here and have a big angle? or the 20 that's closer and have a small angle?
It's
20 that's closer.
The
That's
20
small.
that's closer, I have a small angle. We can also think about looking at the numbers. If I'm starting from 0 degrees and I'm counting up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. That makes more sense than going 1, 2, 3, 4, 5, 6, 7, 8, 9, 170. That makes no sense. We're going to go with the 20 that's right here. So to make that angle, leave your protractor all lined up, and we can just make a little mark. Follow that line out to the end and put a little point here. And then when you move it away, I have a guideline. I'm going to connect these dots. And that is a 20-degree angle. So if it's helpful to have a guide, just remember 90 is straight up and down. If it's smaller than 90, the angle better look smaller than 90. If it's bigger than 90, definitely going to be on the bigger side of things. So there's our 20-degree angle for number 3. We're going to flip the page and look at number 4.
Miss Taylor, can you go back?
Yeah. Here, back to the angle.
Yeah, thank you.
Yes, you are welcome.
Okay, we're good.
All right. Okay, so now going to the next page, we're going to see number 4 is another ray and 145 degrees. So we're left with another question. We're going to first line up our protractors with that ray. And you're going to notice that there's also 2 145s. So I see one right here in between 140 and 150. I can mark that if I want. And I see another 145 right here between 140 and 150. So let's make another little mark here. Which one are we going to use?
Bigger than 90 degrees.
Yeah, we're going to want to use the measurement that is more than 90 degrees. That's going to give us a bigger marking. I marked that on the wrong spot. So would it make more sense? Goodness. Would it make more sense for our angle to be the one over here? Let's call this A. Or would it make more sense to use B?
Okay.
A will make an angle that looks like this. B will make an angle that looks like this.
B.
B. Why should it be B?
That is bigger.
Because it's bigger. It's bigger. 145 is bigger than 90. So it's going to make more sense to have an angle that's bigger than 90. So let's connect the dots here. This is much more like 145 degrees. If I would have used my A marking, I would have really had an angle that was really 35 degrees. Because I'm looking at the inside numbers. That's a 35-degree angle. We want the big one. Oh, I'm sorry. Here. Can you see this okay?
Yeah, that number.
Okay.
This one here.
Which part do you need to see?
Yeah, that number.
Right
Oh,
here.
45.
So there's 140, 150. So 145. It's right here in the middle.
Thank you.
You're welcome. So there's your 145. It should look about like that. And you can see that my line crosses in between 140 and 150. Okay. Any questions about number 4, or does anybody still kind of need to see it? Okay, I'll leave that up and try to hide the glare so y'all can see those numbers. Okay, can we look at number 5, 6, 7, and 8? Okay, so now we're looking at angles, and these are multiple choice. You just need to tell me, is it an acute angle, a right angle, an obtuse angle, or a straight angle? So what does acute mean?
Less than 90 degrees
Less than 90. Right?
is exactly 90 degrees.
Exactly 90. Obtuse?
Greater than 90 degrees.
Greater than 90. So I'll try to draw one that's a little bigger. And straight?
Exactly 180 degrees.
Oh my goodness, yes, exactly 180 degrees. So these are little drawings of each. That all should be in your notes as well. We took some notes about this. So number 5, what's this?
Straight.
Straight. That's a straight angle. C. Number 6.
Obtuse.
Obtuse. It's not fully straight, but it's more than 90 degrees. Number 7.
Obtuse.
Obtuse. Oh, that's tricky because it's kind of flipped around. We're still looking at the angle. We have to kind of rotate it in our mind, but this is bigger than 90 degrees. This is obtuse. Number 8. This one's kind of mean because I'm not even really sure.
It's a right angle.
It looks like a right angle. It certainly looks like a right angle. Although I'm never going to ask you something like this as like a trick question. If it's a right angle, I'll put a box in it. Okay. So go ahead and pretend that there is a box. You can draw one in. Now, what is it? A right angle. Good. That's a right angle. Okay. Wonderful.
That could be 91.
Right. Could be 91 degrees, and I would never know. All right. So there is number 5 through 8. Let's look at the next page. Okay, so now it says solve for x, and we are using parallel lines and those angle relationships. So remember with these problems, we have 2 options. Are they equal to each other? Or do they add? Yes, they add up to 180. Those are our 2 options. So for number 9, what's a good way to figure out if they're equal or if they add up? We used a special method where we drew something. Does anyone remember that?
It's a long line.
It's a long line with a lot of other lines.
Then we did a circle.
Yes, circles. Circles are a great way to help with this. So what I'm going to do is, now you may already see right away what it is, but if you don't, I'm going to say, let's draw circles over our X's where the lines cross. And then I'm going to see what's equal to 59. So in these 4 angles, is there one that's equal to 59?
Right across.
Right across from it is equal. Yes. And we also know that any of the angles that are in the same position as the top circle are equal. So what else can I shade in that's equal?
Right there by the 9 and across from the 9.
Yeah, 9 plus 10x is equal because it's the top left of the circle, and across is also equal. So now what can we say about 59 and 9 plus 10x?
That equals
3.
They're equal. They're equal. That can definitely make writing your equation a lot easier. So I know these are equal. So with that in mind, I know they're equal. What equation could I write?
Minus an X.
Plus 59. So did we decide they're equal to each other or do they add up to 180?
Equal.
Yes, good, good, good. Okay, so we have 9 plus 10x equal to 59. No 180 needed. Okay, so now that my equation is written, go ahead, Melena.
Could you do the opposite way, like 59?
Yes, you could absolutely do it the opposite way. You could also do 59 equals 9 plus 10x. That would also work. And then once we have our equation set up, what is a good next step? Yeah. So you said 9 minus 59 or 59 minus 9?
59 minus 9.
Okay, so I want to listen to both suggestions. I'm hearing subtract 9 from both sides, and then I'm also hearing subtract 59 from both sides. So if I subtract 9, that gets rid of this 9, and I subtract 9 here,
You get 50.
then I get 50. If I subtract 59 here, I have nothing left. I'm thinking minus 9 is probably our best option here. If everybody's okay with that. Okay, so minus 9. Do that. Minus 9, minus 9.
Your nines cancel.
My 9s cancel.
Bring your 10X equal. Yeah.
Bring my 10x equals,
50.
and 59 minus 9 is 50.
You just divide by 10 on each side.
Yes, then we just divide by 10, and we'll have our x.
Your 10 will cancel.
Hmm?
Your X equals 5.
Perfect. X equals 5. Very nice.
Nice.
I know, I like when they cancel nicely. Right, right. Okay, so there's number 9. Now, number 10 is similar, but slightly different. I'm gonna do that circle trick again. Because before we do anything, we want to decide, are they equal to each other or do they add up to 180 degrees? So let's see where the positions are. I'll start with my 18x plus 8. And I know that if it's across, it's equal. So I'll color the circle part across. And then when we go down to the other circle, we want to color it in the same positions. So we've colored the top right and the bottom left. So again, I'm going to color the top right and the bottom left. Now that we have things shaded in, what do we notice about our two marked angles? They're not equal to each other. They're not both shaded in or they're not both unshaded. So if they are not equal to each other,
They add up to 180.
they add up to 180. Good. So what equation will I write?
You can do 18x plus 8
Mm-hmm.
plus 16x plus 2 equals 180.
Perfect. We'll do 18x plus 8 plus 16x plus 2, yes, equals 180. we have it all written out.
You combine your like terms.
Yes, we want to combine like terms. So I'm gonna look at my x's. I have 18x. I have 16x.
You add those together and it gives you 34.
Yes. Just gonna add them together. 18 plus 16 is 34x. And we could bring everything down, but if you like to combine everything all in one step, what else could we combine?
You're 8.
8 and 2.
You give you 10.
That does give me 10. Now I have 34x plus 10, bring down, equals 180.
Then you subtract 10.
Yes, Riley.
Yeah, I was just wondering, I subtracted, 16x.
Subtracted 16x.
Yeah, like cancel out the 16 and then subtracted it from 18. I
Okay.
don't know if that was right.
So if you had 18x on the right side and then 16x was on the other side of the equal sign, you could totally do that. But since they are on the same side of the equal sign, we combine by just adding. So that's the difference. If your x's are already together, you can just add them. If they're on opposite sides, that's whenever you subtract and cancel. Okay, so we have 34x plus 10 equals 180. What should I do next?
Subtract 2.
Yeah, let's subtract 10.
10's cubed. You get 34x equals 170.
34x equals 170.
Then you divide by 34.
Beautiful. Divide by 34.
Your 34's cancel. Your x is equal to 5.
70 divided by 34. Yes. You will get x equals 5 again. Oh. Awesome. Okay. That circle trick helped. I feel like it helped me. Honestly, we didn't have that trick last time I taught this, and that would have been really helpful. I like it. Okay, guys, so that's number 9 and number 10 with the parallel lines and angles. So I'll leave this up for a second, but we are going to move on after this to something called midpoint. Was that in the video at all on Thursday? Did y'all hear about midpoint? Okay, so this will be new. So instead of working on this worksheet, once you're done copying this down, go ahead and pull out your notes. And we're going to take notes on how to do the rest of this. That way it's not just floating around in a worksheet. You've got it in your notebook. Now that's different, but that is what was on day 4. We didn't do midpoint formula though. That's new. Okay, so I'm gonna move that to the side, and I'm gonna title my page. So geometry. Day 5. October 13th again. Okay, so we are going to talk about how to find the midpoint of a line on a graph using coordinates. So up here, we're going to write midpoint formula. Midpoint is exactly what it sounds like. It's the point in the middle. And we're going to write a formula here. So we will start with, I'm going to use some colors here. X1, 2. Let me make sure I give you the correct plus and minus and everything.
Just like we did, algebra 2.
Very
X1,
similar.
X2,
Yep.
Y1, Y2.
Yes. Okay, so x1 minus x2. I believe. Oh, I'm wrong. Plus, turn that to a plus. X1 plus x2 divided by 2. That's what we start with. And now that you know what size this is going to be, I'm going to put a big parenthesis outside of it because this is going to give us a coordinate. So x1 plus x2 divided by 2, big parenthesis, comma. This will give you your x value. Now we're going to do y. It'll be the same thing. y1 plus y2 divided by 2. And then close the parenthesis. Once you have the midpoint formula, I'm also going to give you the distance formula. 2 formulas. So for the distance formula, we are going to do x1 minus x2 this time that goes in parentheses. X1 minus x2 squared plus on the outside y1 minus y2 in parentheses squared. Once you have all of that, the whole thing goes under a great big square root.
Okay, then.
Lordy. Sorry,
They
guys.
don't like us today.
I know. And this looks like a lot, and it always looks really scary before you use it. But once we run through how to use these formulas, you will see that it's not so bad. Promise. So we have a midpoint formula and we now have a distance formula as well. Everybody's got those down. Once you've got them, we're going to look back at number 11 on our worksheets. Anybody still need more time to copy these down? Or can I move? Okay. All right, I'm going to scooch this to the side for a moment and let's look at number 11. Number 11 says find the midpoint of the line segment with the given endpoints. So these are my endpoints. -3, 10, 7, -5. So the very first thing we need to do is label our points. So I'm going to rewrite them a little bit bigger so it matches the rest of my work. You don't have to rewrite it, but I'm going to. -3 and 10, and then 7, -5. And thinking back to algebra, when you have a coordinate, what comes first, x or y?
X.
X. So I know that this is an x, -3, and 7 is also an x. So 10 and -5 must be my y's. Now, as far as figuring out x1, y1, x2, y2, all we're going to do is say, well, I'm going to say this is my first coordinate, so this will be x1, y1.
X2.
And then the next one is just x2, y2. That's it. x1, y1, x2, y2. And once you have your coordinates labeled, it's going to make it a lot easier to use the formula. So what I like to do when doing midpoint is I'm going to write out n for midpoint equals, I'm going to give myself a big parenthesis with a fraction and another fraction, close my big parenthesis. I know I'm dividing by 2 on both, and I'm adding something on both. In my first blank space, I need x1 plus x2. So what's my x1?
-3.
-3. x2?
7.
7. Done. Then I need y1, y2. So what's y1?
10.
10. y2?
-5.
-5. Beautiful. My numbers are plugged in. We're halfway done. So now all we have to do is solve each one of these. It's like 2 separate problems. First, I have my x's. I want to add what's on top and then divide by 2. Do not type this in all at once because your calculator is going to do the division first and you'll get the wrong answer. Let's go one step at a time. So I'm going to look at -3 plus 7 first. And that gives me
+4.
+4. I'll bring down over 2. And then I'm going to look at 10 plus -5.
Be +5.
That will give me +5. Bring down my over 2. Now there's just one more step.
Right.
Divide it. What's 4 divided by 2?
2.
2. 5 divided by 2?
2.5.
2.5. And so, that is your answer. You remember this? Okay, so not so bad. Not so bad. We'll do some more practice with that here in a minute. But that is number 11. There's your midpoint. Do we have any questions about number 11? Did everybody get that one okay? No, it's new. Okay. We will go ahead and flip to the next page. Oh, you still need it? That's okay. Here, I'll leave it up for a second. Yeah, definitely don't be scared to let me know if you need to still see something. Happy to go back. Okay, got it. All right. So now, last one here. Distance. Now we're using the distance formula. So, same process. I'm going to make my coordinates a little bigger, and we need a label x1, x2, all that stuff. So 7, like 5. Okay. So remember, we want to do x1, y1, x2, y2.
Your X1 is 7.
Yes.
Your X2 is -5.
Good.
Y1 is -5. Y2 is -6.
Good. X1, y1, x2, y2. Now, we have our points labeled. All that's left to do is plug them into the formula. So, the distance formula. Start with our big square root. And I know I'm going to subtract 2 numbers in parentheses and square them. I'm going to add 2 other numbers subtracted, squared. Remember, we're putting in here x1, x. So once you have this, just need to decide what goes where. And we want to be really careful when we're using formulas that have subtraction, especially when there's negative numbers. Because, for example, when I plug in my x1, x2, what numbers am I writing?
Your X1, you're gonna write 7.
Okay.
And -5.
And -5 for x2. Now, it is important to know that the minus is already part of the formula. So we have minus -5. What on earth does that mean?
It's
It's going to become a positive. So if you don't want to remember a rule, you can always rely on your calculator. I can say 7 minus -5 is 12. Weirdly enough, this is the same thing as 7 plus 5. 12. Minus negative. It's like these 2 little signs just can't help it but join together and become a plus. Just can't help it. I need another green pen. I've been looking for one. Okay, so these become plus. That's important to know. And if not, as long as you can type it on your calculator and get the right number, that's really all that matters. So I know that this is 12. And I need to bring everything down. I still have parentheses. What's outside of my 12?
Square.
Squared. Don't forget your exponent. That needs to come down. Plus y1, y2, what goes there?
-5, -6.
Yeah, y1 is -5. Y2 is -6. So I have another minus negative. So it really is plus -5 plus 6 is 1. But what comes down?
Your square.
My square. So this goes back to the order of operations where you have parentheses first. We did what was in parentheses first. Now exponents. So I brought everything down. What is 12 squared?
144.
144. Remember that squared means I'm taking it times itself. Do not do 12 times 2. That would not be correct. It's 12 times 12. Yeah, 12 times 12, which is 144. Plus, what's 1 times 1?
1.
1.
It'll be 145.
Yeah. But what are we missing? What did I not bring down in the second step? My square root. Oh my gosh. So I gotta bring it down again, don't I? 144 plus 1 we said is 145. So D equals the square root of 145. You're going to get a decimal. Let me remind you how to use the square root button on your calculator. You will need the blue second button, which, by the way, if any of you do not have a yellow calculator at your table, I'm happy to pause and wait. Everybody is a calculator today. So I'll pause my recording for just a minute and let you guys grab one if you haven't yet. As a quick review, to access the square root key on your calculator, you'll need to hit that second button, the blue button, and then you'll look for the button that says x squared. Above it, you'll see a blue square root. When you hit that blue second button, you're accessing the blue keys. So click that. And now I have square root on my screen. I'll just type 145, enter, and I get 12.04 and then a bunch of other numbers. I will not be picky for how many decimals you give me, but if there are decimals, don't just write 12. That won't be correct. Make sure you give me at least 1 or 2 points. So 12.04 would be a great answer here. D equals 12.04. And that would be our answer. That would be our answer. Okay. So there's an example of the distance formula. And then these are just some fun extra bonus random ones. Not necessarily something we have to go through. What do you think? No idea. That's okay. That's all right. Info. So we can come back to 13 and 14, but I would love to ask you guys, take a second, flip through everything that we just did, and tell me, what do we feel the least confident on? What do we feel like we need the most practice on, other than what we just learned? We just learned distance formula and midpoint. Construction. Yes. Okay.
Yeah.
Construction.
Stuff. Yeah.
That's right. So that's what was missing on this worksheet. Okay. So Thursday, whenever I was not here, something you guys did is constructions. I didn't put that on this worksheet. So in until we do a little more on this, let me put this to the side. And I would love for all of you to get out your compass. There might be compasses at your tables. If there's not, there's extras on the wooden shelf at the front of the room. Okay, everybody got a compass? Here's what we're gonna do. We're gonna take some notes, make sure that we feel good about constructions. So what I'm gonna do is flip my page and start page 2 of my notes. And we are learning about 2 specific types of constructions. So I'm going to name this constructions. Really what this means, have you ever heard of a construction worker? Somebody that builds things? Those workers use these basic constructions that I'm about to teach you to make sure that their drawings and their building plans are precise and accurate. So this is an excellent skill to have if you're planning on going into a trade where you're drawing out maps and plans and things. It's also great for, I don't know, all sorts of things. I use my compass a lot of times for different crafts and hobbies. If I'm wanting to make like a perfect curve or a perfect circle. So the 2 main constructions we're going to talk about are the perpendicular bisector.
Big word.
Them big college words.
Right. We're going to construct a perpendicular bisector and then an angle bisector. So, first one, 2 big words. Perpendicular. Perpendicular. Perpendicular bisector. bisector. Perpendicular bisector.
Salad. Looks how it's spelled.
Right. It looks just like the way it's spelled. Perpendicular bisector. So does anybody know what perpendicular means?
Like
You used to. Okay. It's somewhere in there. Anybody know? Cross.
Eagle.
It has to do with an angle. Okay. Perpendicular. Here's what it means. So there are kind of 2 main ways that we can think of lines in terms of like very special relationships. I'm going to use a sticky note here because I don't want to write all over this. But we've already learned about parallel lines. Lines that never cross. These are parallel. Perpendicular do cross at a 90-degree angle. So perpendicular. So with this construction, you're going to start with a line, just a regular line, you will be constructing the line that splits it perfectly in half and goes at a 90-degree angle without measuring, without using a protractor. You won't have to do any measuring other than what this fancy compass can do. So I'm going to move this, and underneath the word perpendicular, I'm going to make a little note that says 90 degrees. Bisector. Does anybody know what bisector might mean? Kind of hinted at it. Yes, 2 sections. Bi, the I, that prefix means 2, like the number 2. Sector means sections, 2 sections. So we're splitting it in half perfectly at a perpendicular angle, a 90-degree angle. So 2 sections. And what we will do for a perpendicular bisector is first we need to start with a line segment. If I don't want to go to halfway of my page, I'm going to do it about here. Let's see, that would be about, I'm drawing my line about 2 inches under the title, about right here. And I'm only going to make my line about 3 inches long. 1, 2, 3-ish. About 3 inches long. I'm going to give it end points. If you have that drawn, you're going to want to pick up your compass. If you have a compass that is loose, meaning when you kind of open it, it opens really easily, get a different one. You want one that's tight and hard to open. It shouldn't be super easy to move around, because whenever we're drawing our little markings, our arcs, if you have a loose compass, your lines are going to be wiggly, and we want them to be really precise. So make sure that you got a stiff one, and if you don't, go switch it out for a new one. So when we have our line segment, to create a perpendicular bisector, we start with our compass, and we have a pencil side and a point side. I'm going to put the point on one of my end points. And I'm going to make sure that my pencil is farther than halfway. I want this to be open more than half of the line segment. From that point, we want to keep it open at the same length, and we're going to mark an arc like this. Oops, that's why I gotta be careful. I messed up. So I've made a little arc. Now, making sure that you don't change how open or closed your compass is, keep it at the exact same width. You're going to pick your compass up and put the point on the other end point. And make an arc again that crosses the first arc so that you have an X. Once you have your X on top, you're going to do the same thing, but under the line. So I'm going to make sure that it's still open to the same size. Back on the first point, make an arc. To the other point, make sure it's open to the same size. Cross that other. Now I have 2 intersections. So you're making 4 arcs, 2 on top, 2 on bottom. If you're somebody that likes to do things in as few steps as possible, technically you could do both arcs kind of at the same time. You'll notice like this one connects. I could just do one big arc all the way there. And I could do a second arc going all the way, connected here. As long as you have the intersections, that's all that matters. You don't have to have it crossing through the line. So everybody to this point. We need a minute. Okay. Hi.
I have a question, so this is not the classroom, I'm supposed to be, I'm supposed to be over there.
Okay.
Whenever you get the chance, when you look at your email and look at the certificate, would you be okay with handwriting all of their names?
I'm sure I wouldn't mind.
If you have
I'll
my
look at it. I'll look at it. Hang on.
Yeah, I meant to go.
Okay, so once you have your arc, all we have to do is one last step. Notice we have two intersections. Intersection on top, intersection on bottom. Those intersections are going to create a perpendicular bisector. We just line up some sort of straight edge. It can be a ruler, it can be a protractor. I use a ruler because it might be easier for you guys to see. And we just draw a line that goes through those points. Like that. And all that's left to do is to mark two things. We have to mark that this is a 90-degree angle with a box. And we also have to mark that we have officially cut this line segment in half. So to show that these two lines are equal in length, we put a tick mark. One tick mark on each side. And that shows that they are equal. And your perpendicular bisector is done. There you go. That's you. So if you're really just looking for these two x's, that's all you gotta be able to do. So once you have your perpendicular bisector kind of drawn on there, the next one is the angle bisector. And then after we do this, I'll let you guys take a break. Can I move this up? I'll leave it where we can still kind of see it a little bit. Okay. So for the angle bisector, we can draw all sorts of different angles. I'm going to start. Let me make this a little bigger. I'm going to start with a line that's tilting kind of this way. We're going to make an obtuse angle. You can't see it on my screen yet, but I'm drawing another ray coming out like that. Here is my angle, and we're going to mark the vertex. So if you were here on Thursday, I know that you made a guide to help you with the angle bisector. So if any of you have that guide, can anybody tell me what the first step is? I think it was like on the back of the do now, we did it. Step one, say.
You have a picture of it, it's the point of the compass on the vertex. Create an arc.
Okay, so place the point of the compass on the vertex. That's right here. And we're going to create an arc. So this first arc needs to go inside the angle and it needs to cross both of the rays. So I'm going to do this. Sometimes it's easier to move your paper and hold the compass still. So I'm going to touch down here and then I'm going to turn my paper. There we go. And this time, it actually is okay if you have it open smaller or bigger. Angle bisector is not as picky.
I was just gonna say, I took a note that, you had mentioned in the video, the compass should be less than half of the length of the ray.
Yes. Now, technically, you can make it bigger. The reason I say not to is because if you make it too big, your markings are going to go way off your page.
Right, yeah.
So keeping it small is better for the angle. So that was step one. We made an arc on the vertex inside the angle, and we've made two intersections, haven't we? We made an intersection right here and right here on the edges of that ray and the arc. So the next two arcs we'll make, the point of our compass should go on those intersections. So I'm going to put the point of my compass on my first intersection right here. And we're going to make an arc inside of the angle again. Oh goodness, it's tricky. So there's an arc. And I put my point here to make that. Once I've made my second arc, where do I go next?
Yeah.
The other point, the other intersection that we made. Now for your third arc, you just need to make sure that you're crossing through your second arc at some point. So there we go. That is my third intersection right here. Mark it. So this is the point that we're looking for. An angle bisector splits our angle perfectly in half without using any measurement tools other than the compass. So all we have to do now is connect the vertex to that third point that we made. And we'll want to trace through those lines, those points, and now we have an angle bisector. Our angle is cut in half perfectly. And all we need to do to mark that these angles are equal is put the same number of arcs on each angle. I can put one arc here, one arc there. If it feels better to put two arcs, since we already have one arc on the big angle, we could do two arcs. Whatever works. And that is our completed angle bisector. Okay. Yeah, yours looks good. Your intersection is just, instead of being on the outside of the circle, it's on the inside. Can I show yours actually? Okay, so I want to show Seth's angle bisector because yours might look like this, depending on how big you opened your compass. So notice how my intersection is outside of that first arc. Seth's intersection happened inside of the arc. That's okay. As long as there is an intersection, it will work. Now, if there is no point where it crosses, that means that your compass is not open up big enough, and you just need to make it bigger so they will cross. But this is still correct. It's just in a different spot, and that's okay. Here you go, Seth. Thank you. Okay, do we have any questions about these constructions? We'll do some more practice with them too. I'm gonna print off.
I think that's mainly my thing, is just being able
Practicing.
to practice it
Right.
more.
So what I'm gonna do is during your break, which I'm about to give you, I'm gonna print off a bunch of practice problems where the angles are already made, your line segments are made, and you can just do some constructions, really get it to where you're feeling comfortable. And then I also want to give you some coordinates so that you can practice the midpoint and the distance. That's also new. And we will spend some time reviewing all of that. But it is almost 2:10. So I'm going to let y'all have a break. And we will come back in 15 minutes at 2:25. So take a break, do what you got to do. I'm going to make you guys some practice stuff, and I will see you in a moment. So we are back from break, and I made 2 different worksheets that each of you should have. One worksheet shows constructions. So this one should be at your desk. If you don't have it, let me know and I can get you a copy. But there are 4 line segments and there's 2 angles. So you can use this to help you practice constructions. And I'm happy to check those. This is not for a grade. I'm not grading this. This is you for practice for you. Okay. And then I put another worksheet out that I didn't keep a copy for myself. I should have. It's got a bunch of coordinates, and some of those coordinates you're going to use to find midpoint. Some you will use to find distance. Here it is. So in this worksheet packet, says find the distance between the pairs of points. Round your answer to the nearest 10th if necessary. You have been given 10 sets of coordinates to practice the distance formula. And then numbers 11 through 20 say to find the midpoint. Now you can find the midpoint or the distance for any of these. It's just points. So I will work on making an answer key for all of these so that you guys can check your own work and save everybody a little bit of time. But this is basically what we're going to do I'm going to set a good 30-minute timer for you guys to just work on whatever you choose. When that timer is up, we can answer any questions, review things if needed, and I will also be working on making you an exit ticket today. So I'm going to go ahead and set that timer, let you guys do some work. I am up here available to answer questions if you need me. But in the meantime, I'm going to be making answer keys for these so you can check your work. I'll pause our recording and let you guys do your thing. All right, so if you were working on the distance formula worksheet and midpoint formula worksheet, I'm going to give you guys those answers. So even if you have not finished them, you can at least write what the answer should be so that you can practice and check your answers later. And if you get a number that's different than me as we go through this, please stop me and tell me because I did these very quickly. I make mistakes sometimes. So tell me if I did, if you catch it. So for number 1, I got a distance of 7.62 approximately. Number 2, I got approximately 7.61 or 6.71. Sorry, guys. Dyslexia. And for number 3, I got 12.73. Number 4, I got 4.12. Yes. 12.83? Is that what you said? Okay, so 0.8. So did you?
Right, the rest, so.
That's okay. Did you just round up to 12.8 maybe? Did you start with the square root of 162? I don't know if you have that written. 164. So let's go up even further. Did you have -9 squared plus -9 squared?
Oh, no.
What did you have?
-8.
Good. -8 for both of them?
No, -10. squared and plus, I think 8 squared.
Okay, -10 plus -8. So let's see if I did something wrong or if it's misplaced a part in our formula. So you need x1, is it minus x2? Yeah, x1 minus x2 squared. So my x1 is -8 minus my x2, 1. So -8 minus 1 squared.
Oh, I see where I messed up.
Plus, you do? What did you do?
I did for 1, 2 at the top.
Yeah.
I did the y first and then X plus.
Ah, okay. That makes sense. So we just mixed up our numbers a little bit. That's all right. Well, I'm glad you see it. Good deal. So I must have done it right, actually. So -8 minus 1 is x1, and then the other numbers would be -7 minus 2 squared. And I just changed those to plus negative in my word. Because for me, it made more sense in my head to have plus and negative than minus, which you can do that. Okay, so for number 3, we should get about 12.73. Number 4, I got about 4.12. Okay, anybody need to see other answers on this page before I move on?
Go over 2
Yes.
together.
Number 2. So let me do paper. Number 2, my points were, I'm just going to write this and then I'll move my page. -1, -3, and 5, -6. Okay, so we're looking at number 2 right now. So we're using the square root of x1 minus x2 squared plus y1 minus y2 squared. So I'm going to put my minuses in. Okay, so what did you put in your first 2 spaces?
I think I screwed it up,
You think so?
but I don't know.
Okay, well, let's find out.
Okay, I did -1,
Mhm.
minus +5.
Perfect.
Is that it? Okay.
That's it.
Okay.
We have x1 and that's x2, so that's correct. And then y.
-3
Mhm.
plus -6.
Okay, so that's where I think you might have messed up. -3 is y2 or y1. Gosh. y2. So we have -3 minus -6. You did plus -6.
Oh, okay.
I know those 2 formulas. So easy to accidentally put a plus.
Yeah.
I know.
Okay.
So that's
makes
probably where you
more
went
sense.
wrong. Let's see. Pause it for just a second. Okay, so if we were to finish this one just for fun, -1 minus 5 is -6. Bring down my square plus -3 minus -6 is really the same thing as -3 plus 6. Should give us +3 squared. Bring down my square root, and then I keep going. -6 times -6.
I have a quick question.
Yes.
I think what's messing me up is that like there's a subtraction sign and there's an implied plus sign in that first one.
In this first one, where it's
The -1 minus 5.
Mm.
See what I'm saying?
So you could think of this as plus -5. Basically the rule with subtraction is keep, change, change. So we can do this with any subtraction problem. I'm going to give you some examples. So this is just an extra note if you're somebody that struggles with subtraction sometimes, because it is one of the hardest things to learn. Subtraction, for some reason, it's the hardest. So we have, let me give it like a bunch of random examples. 2 Okay, here's a bunch of random problems. And I'm going to rewrite that rule. It's keep, change, change. And here's what that means. Anytime I'm subtracting, because subtraction is weird, it's just a weird thing, we can turn it into addition using keep, change, change. So here's what that means. Right here I have -2 minus 3. I'm going to keep my -2. So there's my keep. I'm going to change minus to a plus, and I'm going to change +3 to -3. And now I have -2 plus -3. We kept it, we changed it, we changed it. -2 plus -3 is -5. We can do it with this one. This one isn't the smartest one to do it with, but we can still do it. I'll keep my 4, change my minus to a plus, change my +2 to a -2. 4 plus -2 is the same thing as 4 minus 2, which is +3. I can do it here. -3 minus 6. Keep the -3, change the minus to a plus, change the positive to a negative. Keep, change, change. Now it's -3 plus -6, which is a lot easier than -3 minus 6. I just add 6, 7, 8, 9, -9. You can do it with these too, especially. Keep the 2, change the minus to a plus, change the minus to a plus. 2 plus 5, 7. It's interesting, but it works every single time. Keep, change, change. 3 minus -6. Let's do 3 plus +6. Yeah, and that is +9. So keep, change, change. When you're subtracting, you can do that. Technically, you could do it with addition too, but it's just going to change everything to subtraction. Like 3 plus 5. Weirdly enough, it's the same thing as 3 minus -5 by change and change again. Now, again, these are just extra rules that will help you do things more quickly if you know them, but you can always rely on your calculator. You'll get the right answer if you type it in right. But of course, if you know this rule, it can make your hand work a lot faster. So hopefully that little trick can help a little.
Yeah, for sure.
Good.
I appreciate it.
Good, yeah, absolutely. Okay, so I'm going to go back to giving you guys answers, and we're going to flip to the next page. Number 5, I got about 8.06. Number 6, I got 16.76. And again, if you get something different, let me know. Number 7, I got 6.32. Number 8, I got 16.55. Number 9 and 10, I did not get to. So, sorry, I don't have answers for those yet. But I have answers for the rest. Any questions on this page so far? Okay, flipping to the back. Now we have midpoint formula. So we're looking at an x value and a y value. For number 11, I got -8.53. Number 12, +4.5, +3. 11 and 12. That is 2. Number 13, I got +4, -6. And number 14, -3.5, -6. Copy what's down if you're making an answer key. Or I go to the next page. Does anyone need to see any other things on this page? Go right in front of me. Okay, I'll wait a second. Ready? All right, last page. Number 15, I got 3.5, 2.5. 3.5, 2.5 for number 15. 16, I got +1, -1. 17, I got 0, -2.5. 18, I got 5.5, -4. And last but not least, 19 and 20. 19, I got -3.5, +3.5. 20, I got -4, -1. Those are your answers. Are there any other questions about any of these problems? I'm about to give you an exit ticket. I'll see you later. And for your exit ticket, I'm going to be giving you one set of coordinates, so 2 coordinates total, and you will find the midpoint and the distance. So you're going to use both formulas. And here are your points. And then I'll run copies of this. -5, 4, and 2, 6. So you will want this should be your midpoint. I'll make a space for both so that nobody forgets one or the other. And the distance. So I will freeze my screen. You guys are welcome to start working on this. And of course, it is 3:12. That gives you about 18 minutes to finish this. If you don't finish, it is okay. We've got the whole rest of the week. It's only Monday, and this is due on Friday. Friday, October 17th. So that's your exit ticket. I'm gonna freeze my screen, run some copies. As far as the constructions for this worksheet, if you want me to check your work, bring it to me. I'll take a look at it. These are more individualized. I can't necessarily just give you an answer key without looking at your paper. But this will be your exit ticket. I'll run some copies, and that is all. The end.